Hi there, and welcome to this lesson. In this lesson, we'll be learning about the effects of forces on motion, okay? And under that, we'll be learning about Newton's laws of motion. Now, as the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So, Newton's laws of motion. Now, what is a force? Basically, we all have an idea of what a force is, but in physics terms, a force is any interaction that, when unopposed, would change the motion of a body, either causing it to accelerate or change its direction. Okay, and now basically, if you think about it, if you have, let's say, you have anything at all, an object, and you apply a force to it, you would obviously change from a state of rest. You change cause the object to accelerate, cause the object to move. Or let's say you have an object moving at uniform velocity in one direction. You apply a force, it still maintains that velocity but moves in a different direction. So basically, a force is any interaction that, when unopposed, will change the motion of a body, causing it to either accelerate or change its direction. Now, the unit of force is Newton. Okay, so basically Isaac Newton did a number of experiments on forces and how they result in motion. And basically the unit of force, the standard unit for force, just like you have kilograms for mass, is Newton. And there are three Newton provided three laws of motion. Okay, three laws of motion that describe the action of forces on bodies and how they result in motion. Okay, and basically in this lesson we're going to be talking about Newton's three laws of motion now. Three laws of motion. Now, the first law, Newton's first law of motion, and it states a body will remain in a state of rest or motion with uniform velocity unless acted upon by an external force. Basically, just from the definition of what a force is, it just says that a body would remain in a state of rest. Okay, it will remain as it is unless acted upon by an external force. Okay, so in a state of rest or moving with uniform velocity. Now, here's something you need to understand. If you if you throw something up, basically it comes back down. All right, now you apply a force to that body, and you set it on its path, okay, in motion. And then basically normally that body would continue to move at a given velocity or continue to accelerate as a result of the force that you applied. But the only reason that that body stops is because an external force, the force of gravity, acts on that body and stops it and then returns it back to the Earth's surface. But typically, if you apply a force to anything at all, for example, if you push something on your desk at the moment, basically normally that body should continue to accelerate as a result of that force. But then the only thing stopping that body from continuing in that state of motion is friction, basically friction between the body and the surface. Now, that's Newton's law, or first law of motion, and also says a body acted upon by two equal opposite forces would also remain in a state of rest, and this body is said to be in equilibrium. So we have these two bodies, we have A and B, and A has two equal forces acting on it, and then B has a larger force on the left, a smaller force on the right. And what you have is you have a resultant force where you bring two of them together. The total resultant force acting on A at the moment is 0, okay? And for that reason, A would stay stationary, okay? And then you have a resultant force, you have a larger force pushing B to the right, and you have a smaller opposing force pushing it to the left. And what you have in the end is you actually have object B moving or accelerating to the right. Okay, so that's pretty much it for Newton's first law of motion. It's pretty much just what a force is, and it states that a body would remain in state of rest, or in a state of motion with uniform velocity unless acted upon by an external force. And it's also called the law of inertia. basically. Okay, so let's talk about Newton's second law of motion. Now, second law is the most interesting one. And basically, we have that when an external unopposed force acts on a body of constant mass, the object would accelerate in the direction of the force. Okay, now, when you apply a force to anything with a given constant mass, okay, basically anything at all, everything, all matter has mass. But basically, if you apply a force to a body, the force would cause that body to accelerate in the direction of the force. And what you have is you have a body like this, and the body has a mass m, and you apply a force to this body, a force F, and it will cause this body to accelerate. Okay, very important there, accelerate. And what it is it accelerates in it will accelerate in the direction of the force. You have acceleration A. And we can actually relate all three parameters together. Basically, what you have is you have that the force applied on the body is a product of its mass and its acceleration. So if you apply a given force to a given mass, basically the resulting acceleration will be the force divided the magnitude of that force divided by the mass. Okay, and that's it, pretty much it for Newton's second law of motion. When an external unopposed force acts on the body with a given mass, the force would cause the object to accelerate in the direction of the force. And now let's talk about the third law of motion. It's a very, very simple one. And basically this one says every action force has an equal and opposite reaction force. And this is, in practical terms, one of the very, very, very important law of motion, basically, because this is actually what helps us walk. And if you think about it, when you're walking, you're actually pressing your foot against the ground somewhat backwards. Okay, you're walking, and it is a reaction force that gives you the push forward. If you study exactly how you walk, basically when you're walking, you're pressing your foot backward. Okay, and it's the reaction that the floor exerts on your foot, the opposite force that actually pushes you forward. Or if you think about it, when you're running, you're pushing against the floor. Okay, so you're exerting a force in the opposite direction, and then you have a reaction force pushing you forward. But let's understand what this is. Basically, if body A exerts an action force on body B, okay, so you have two bodies in contact. Okay, as I just explained, there's you and the floor when you're walking or when you're running. If body A exerts a force on body B, body B in turn exerts an equal and opposite reaction force on body A. Now, here's something to think about. Let's say you're swimming, okay? You're swimming and you want to swim, and you put your legs against the edge of the swimming pool, okay? And you press against it. You press, and then you release, okay? When you release, there is a force that propels you forward. Basically, you've pressed back on the edge of the swimming pool, basically on the surface, on the edge of the swimming pool. But then when you release that force, there is a force that propels you forward. Now, what that force is the reaction force that forms as a result of your action on the edge of that swimming pool. And this is what it looks like basically. If you apply a force in this direction, there is a force on the body, there is a force, basically the force, the body will respond, okay, and it will give you a reaction. Or just think about this as a a something lying on a surface. Okay, now there's a force that this item applied, that the item would apply on the surface as a result of its weight. Okay, and what I tell you at this point is there is a reaction force. The surface responds to this force. Or if you think, let's say you have a Coke can, okay, and you start pressing against the can, you see that when you press against the can in some way pushes back against your hand, and you start to feel the force of the can on your hand. Okay, and basically, obviously, you probably have this can on the surface, and as you keep pressing through, the surface would also press back, okay? And what you have in the end is the can would actually have to give way, okay? Because you're pressing the can down and the surface is pressing back. And what you have is you have some form of compression, almost as though you actually had the can in your two hands and you were pressing against the can with both hands, basically applying two forces in the opposite direction. So that's what it is basically. For every action there is an equal and opposite. Another good example of this is, think about, let's say you're moving in a car, okay? You're moving in the car, basically you're in the car and you're moving with you obviously if you're moving the car, you would have the same motion with the car. If the car is accelerating, you are accelerating as well. If the car is moving at uniform velocity, you in the car, you're moving at uniform velocity. Basically, there is your relative motion to the car is stationary. So you're sat in one place in the car. Now, if you apply your brake, let's say you apply the brake instantly to that car, what you've done is you've applied a force pushing in the reverse direction of the force that was thrusting the car forward in the first place. Okay, so now you've applied an external force that's going to stop that car, that's going to oppose the natural thrust of the car. Okay, and when you apply that force is pushing back. Okay, what do you think happens to you? There is a force when you apply the brake. There is a force that throws you forward. Okay, basically you have this force pushing back on the natural thrust in the car, because that's the action force. There is a reaction force that actually forms as a result, and this force will push you. You notice when you stop the car, if you're speeding on the highway and you apply the brakes very instant, you see there's this force that thrusts you forward, and that is a reaction force. It's a very, 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 very important one. And then, yeah, let's go ahead now and solve some examples. So I have example one. In example one, we have a shopping cart has a mass of 65 kilograms. Okay, so we have shopping cart mass of 65 kilograms. In order to accelerate the shopping cart down an hour at 0.3 meters per second squared, what force would you need to apply to it? Okay, so we have mass and we have acceleration. We're looking for force. And we know that force is mass times acceleration. So mass is 65 kilograms. Acceleration, you're looking to accelerate. You want to apply a force that would accelerate this body at 0.3 meters per second squared. And what you need, you just multiply the two. And what you have in the end is you have 19.5 newtons. Simple, straightforward. Second example, example 2. A small child has a wagon with a mass of 10 kilograms. Okay, now the child pulls on the wagon with a force of 2 newtons. What is the acceleration of this wagon? So you have this wagon, 10 kilogram wagon, and this child is pulling on this wagon with a force of 2 newtons, and we're looking to find, obviously, the wagon will start to move, it will start to accelerate, and we're looking to find this acceleration. And we just go ahead and we say force equals mass times acceleration. Acceleration would equal force over mass. We have our force in this case as 2 newtons, mass as 10 kilograms. And we just work that, and what we have in the end, we have our acceleration as 0.2 meters per second squared. Simple, straightforward. So that's pretty much it, basically. One thing as regards calculation, the one thing you need to take from this lesson is force equals mass times acceleration. But it's very important that you know about, because we would be talking more about reaction forces in the coming lessons when we start talking about friction. But for now, basically, you have that force equals mass times acceleration. You have the three laws of motion. The first one is pretty much straightforward. Just tells you that the body will stay where it is unless you apply a force to it. The second one tells you that if you apply a force to the body, it will start to accelerate. And this acceleration is dependent on the relationship between the force applied and the mass of the body. And then the final one, every action has an equal and opposite reaction. And yeah. You can go ahead now and add some questions on the worksheet. Bye for now.